Hello and welcome to Chemistry with Mr. Olson. Looks like I'm upside down. Hello. Let's see if we can solve some problems involving concentration. So, here we have question 20 on our solution concentration worksheet. So, question 20 asks, if 80 grams of NaOH is dissolved in water to make 4.00 liters of solution, what's the molarity? Well, let's start with what we know. We know that molarity equals moles over liters. And it's always good to write it down. Molarity equals moles over liters. So we know the liters, and we're asked the molarity. So we need to know the moles, but we aren't given the moles, we're given the grams. But we can convert the grams to moles using the molar mass. So, what do we have here? We've got NaOH. From our periodic table, 23.0, 16.0, 1.0 grams per mole added up, and we get 40.0 grams per mole is the molar mass of sodium hydroxide. So we can take our 80 grams, grams NaOH, and we will do a conversion. We'll go out of grams NaOH, and we'll get into moles NaOH. Out of grams into moles, we always put a 1 in front of mole. So let's see, how many grams per mole? Well, we just figured out it's 40.0 grams per mole. And I love to show cancellations in a different color. The math very easy. 80 divided by 40. 3 sig figs we start with, so that'll be 2.00 moles of NaOH. Now we're not quite done because we figured out the moles, but we really want the molarity. So the equation for molarity equals moles over liters. Formula equals, now we substitute. What is the moles? We have figured out we have 2.00 moles of NaOH divided by, what are the liters? Well, we have 4.00 liters. So 2 divided by 4, that's very easy. We should have 3 sig figs. 3 and 3, the fewest is 3. And so we get 0.500 molar NaOH. Great. That's question 20. There's our answer. We'll box it to make it really clear. All right. Let's move on to question 21. We'll just take a quick look at this. And it's saying how many grams of H2SO4 are in so many liters of so many molar solution. Well, given liters and moles, once again, we know molarity equals moles over liters. So what does moles equal? Moles equals liters times molarity. So moles equals liters times molarity. And we'll be able to get the moles. However, we're not quite done because the question asks for grams. So we will need to convert using the molar mass. So how many grams? Use molar mass to convert. Okay? All right. Next question, 22. So many mils, so many molar. We will, of course, want to convert this to liters. 600 mils with 3 sig figs is, move the decimal point 3 places, 0.600 liters. So we got the liters, we've got the molarity, we'll get the moles, but of course we want grams. So we will need to use molar mass. Okay. Let's see. Once again, convert this to moles using molar mass. Question 25. Question 25 asks us for percent solution. So we just use the formula for percent solution. Percent equals grams of solute over grams of solution times 100%, make it a percentage, equals grams of solute over grams of solution times 100%. Looks offhand like it'll be a little more than 10%. So eyeball your answer, make sure it's right. Okay, let's do another one. This one's an interesting one, number 27. How many grams of CaCl2 is in 84.0 grams of a 3% solution? With this one, let's break it down to a number equals the part over the whole. 3% is 0.03. With 3 sig figs, it's actually that. And we know that that is the part over the whole. That small number is the part over the whole. The part is the solute, and the whole is the amount of solution, which is the 84.0 grams. So, solving for x, we will get the amount of grams, which looks like it will be 3% of that, 2 or 3 grams, something like that. So eyeball your answer. Okay, this one's similar. What's the mass of an 8% solution containing so many grams of sugar? That's the solute. In this case, we have 0.0800 equals the part, the 46.0 grams, over the whole, which is what we don't know. We don't know the mass of the solution. So, that's how we solve that. Now let's do a parts per million one. Well, let's see, this first one asks for, it's got a percentage, it says what's the concentration in ppm. So, this connects back to 100 parts per 100, that's 10 to the 2. Parts per million, that's 10 to the 6th. So they are different by 4 decimal places, or, as a power of 10, 10 to the 4th. So the percentage is going to be the number of ppm. We just need to move this 4 in the right direction. So that would be 130. Let me draw that. 1, 2, 3, and one more, 4. So that would be 130 parts per million. If you prefer, you can use the equation we learned in our notes, which is that parts per million equals percent times 10 to the 4th. So writing that down, parts per million equals percent times 10 to the 4th. So it asks for the parts per million. Oh, we just fill it in and we got it. Okay, that is a good start, and I hope this has been helpful. So, ta-ta, have a beautiful evening. Bye-bye.